Hello everyone. In this video I'll be talking about 11.4 and 11.5. In 11.4 we're going to learn about the square root property and how it helps us to solve certain quadratic equations. And then 11.5 we're going to be solving quadratic equations by completing the square. So these sections that we've seen in chapter 11 are really a bunch of different ways of doing the same thing. So we're in all the sections we're solving quadratic equations, except the method by which we're solving those equations is changing. So what we learned previously is how to solve these things by factoring. And not all equations factor, so eventually we're going to have a more general approach. But just to remind us of that, so if I were to try to solve this one by factoring, I would be looking for a times c. This is our first step. So I'm taking 1 times 14. So 1 times 14 is 14. And then what we did next is we factored 14, looking for factors that add up to b, which is -9 in this case. So we want to see if this is possible. -9. So we're looking for factors that multiply to +14 and then add up to -9 if possible. So -2 and -7 do that. So what we then would do next is we would rewrite this middle term using these as coefficients. So I would write x squared minus 2x minus 7x plus 14 equals 0. And then the next step was to factor by grouping. So factor these two groups. So I'll factor out an x out of these two, leaving behind an x minus 2. I'll factor out a -7, leaving behind x minus 2. So now factor out the x minus 2. And we leave behind this x minus 7. And then zero product property says if we have these factors multiplying together and set equal to 0, that one or both of these factors needs to be equivalent to 0. So we need that x minus 2 is 0 or x minus 7 is 0. So add 2, add 7, and we would get x equals 2 and x equals 7 as our solution. So that was by factoring. So this is not 11.4 or 11.5 yet. That was from our previous stuff. So when we have the square root property eventually, there will be occasions when you're taking a square root of a negative number, which is not allowed mathematically under the real numbers. So for example, if I had the square root of -4, the calculator will tell me, oh, nope, I don't like that. And you might wonder why. So the square root of -4, if that equals the number c, then c times c would equal -4. That's what a square root means. If you're the square root of +4, that's 2, because 2 times 2 is +4. But if we have the square root of -4, and we imagine, okay, that equals some number, then that would mean that that number times itself is -4. And within the real numbers, a number times itself is not negative. Okay, so there will be certain situations where we have a square root of a negative number, but we actually want to be able to say something about that. So on your calculator, see how up here it doesn't say anything, well, it says math, and then it says there's this R there, but don't worry about that. It doesn't say anything else. To deal with something like this, what I'm suggesting is press mode and then number 2. So select CMPLX right there. So press number 2. Now it says CMPLX up there. That means complex. So now when I go square root of -4, it'll actually tell me that that's equivalent to 2i. And I'll explain why in a second. So the explanation is right here. So it turns out that we have defined the square root of -1 to be this imaginary unit I. So applying that here, the square root of -64, I can think of that as -1 times 64 inside of a square root. There's this rule, the product rule, that says I can split up a product inside of a root. So I can say the square root of -1 times the square root of 64 separately, like that. Now, our definition is that if you have the square root of -1 anywhere, that you can replace that with I. So here, I'll have a factor of I. The square root of 64 is 8. So I would have I times 8. And we usually write that as 8i. And I can definitely check. So if I had the square root of -64, that's 8i. For the next one, we have the square root of -11. So I can again split this up into -1 times 11. And that would be able to be split up into the square root of -1 times the square root of 11. The square root of 11 doesn't simplify. And right here I have a factor of I. So this would be I times the square root of 11. Maybe I'll do the last one just purely with the calculator. So square root -48, remember you have to have this mode up there. So that was mode and then number 2 for that to say complex up there. So square root of -48, so that would be 4 root 3i. So 4 root 3, and then I is outside of the root. Sometimes people put this little mark to show that that thing is outside of the root. Or you can bring the I out front and say 4i root 3, just to make it a little more obvious where the I is. Okay. On to page 104. So let's talk about the square root property in specific now. So if you had this situation, x squared equals 16, there are two numbers that multiply by itself to give positive 16. So both x equals 4 and x equals -4 would work. So when we make our algebraic move of applying a square root, we need to make sure that we use plus and minus on the side with the number, or else we're going to miss one of our answers. Okay, so that's what this is saying down here. If you have u squared equals a number, then u equals plus and minus the square root of d, not just plus the square root of d. So we're going to isolate this x squared. So first things first, I'll divide by 4. So I'll get x squared equals 7. And then what this is saying is you go ahead and apply a square root, except on the side with the number, I need to use plus and minus. So these now cancel and I get x equals plus and minus the square root of 7. Just do a quick check just to make sure. So with x equals, let's take the positive case. Let's just check the positive root 7. So the claim is that 4 times root 7 squared equals 28. So squaring root 7, we now have 4 times 7, and that does equal 28. All right, I'm gonna go over to page 105. Try another one. So 4x squared plus 9, again, I want to isolate the thing that's being squared. So I'll subtract 9. So 4x squared equals negative 9. Divide by 4, I'm isolating the thing that's being squared. And now I will take a square root, making sure to write plus and minus on the side with the number. And I'm taking a square root of a negative. So maybe I'll go in here and go negative 9/4, press equals. It's spitting out 3/2 I. So x would be equal to plus and minus 3/2 I. You can certainly check your answers, right? So if I do a quick calculator check, so 4 times 3/2, and then to get to a factor of I is right here. So I believe I need to go shift and then that button. It's kind of weird that it's not yellow, but you still go shift ENG to access I. So now I have I there, in parentheses square, and then adding 9. Right, I'm checking this problem here with our proposed solutions. So I'm just plugging in the plus case, making sure that I indeed get a 0. So I do get a 0. And even if this were the minus case, I still get a 0. All right, so here we have now not just x squared, but we have x minus 3 all squared. So that is the thing that we want isolated. So it is already isolated. So I'll apply my square root, making sure I use plus and minus on the side with the pure number. So I'll just have x minus 3 equals plus and minus root 10. And then add 3. So we have x equals 3 plus and minus root 10. And if you wanted to check that, you could. So one way to do this would be to type in 3 plus root 10. And then if you press enter, that's now saved in memory. And what you can do is go parentheses answer, so this answer button down here. So answer, and then it's x minus 3, so I'll go minus 3, end parentheses squared. I should be getting a 10 out of this or else something went wrong. So that looks good. So here's an application. This is the compound interest formula. So it says, solve the compound interest problem. You invest $3,000 in an account whose interest is compounded annually. After 2 years, the amount or balance in the account is $4,320. Find the annual interest rate. So in this formula, we'd be looking for R. So the amount that we want is this 4,320. So I'd have 4,320 going in for A. This is equal to P, the principal, which was the original investment, times 1 plus R. And then it was said after 2 years. So this is raised to the 2. So what I need to do is isolate this thing that's being squared. So I will first divide by 3,000 on both sides. So 4,320 divided by 3,000 is 36/25, or 1.44. So 1.44 equals 1 plus r squared. And then what I'll do there is I'll take a square root using plus and minus on the side with the pure number. Okay, so on the right, these will cancel. And then plus and minus the square root of 144 will just equal 1 plus r. And then I'll subtract over 1 to solve for r. So I have plus and minus the square root of 1.44 minus 1 equals r. One of these might not make sense. So interest rates shouldn't be negative. If interest rates were negative, then if someone wanted to borrow money from you, then you would have to pay them money to do that. So you would say, hey, your friend might say, hey, give me $100, just loan me $100. And I'll pay you negative 2% interest. Then you would have to pay them $2 to loan them $100. So interest rates should only either be 0 or positive. So let me check in on these. So if you have negative the square root of 1.44, and then you subtract 1, that would make r this number. So I believe we're going to just throw out this negative, because that led to a negative interest rate. If this were positive, then we get this as our interest rate, 0.2. Okay. So r would equal 0.2, and another name for that would be 20%. Okay. On to completing the square. This can be a little challenging at first. So not always will you have a square root present, or will you have something squared present to take a square root of. So in those cases, you'll need to do what's called completing the square, so that you do form something squared, and then therefore you can take the square root and solve by that square root property. So if I were to isolate x squared here, I don't want to do this, by the way, but I would have x squared equals negative 4x plus 1, but I can't have x defined in terms of x, right? If I'm trying to solve for x, I can't have x over here. So I cannot isolate the thing that's being squared solely with respect to numbers. I involve x. It's kind of like if you're defining the word hot. You cannot use the word hot in the definition of the word hot. Right, so if I'm trying to define the word hot, I cannot say such as when the day is hot, right? Because that still leaves hot undefined. So that's kind of like this. If I'm saying x equals in terms of x, it doesn't actually give you a definition for x. It still leaves a question mark. So what we need to do is complete the square. What is being said is if you can identify b, so b for our problem will be 4, then if you add in half of b squared, you'll now have a complete square. So b for this problem is 4, and then what this is saying is to add in half of b squared. So half of b squared would be 4 over 2 squared, in other words 2 squared, in other words 4. So 4 is actually a special number in that way. Half of itself squared is itself. So I will add 4 over there, because that's what this is saying. So I'll add 4, I'll get x squared plus 4x plus 4, and then I'm just scooting that negative 1 kind of out of the way, equals 0. But I just added 4 to the left, So that means I also need to add 4 to the right. So I not only need to add it over here, if I add something to one side, I also need to add it to the other side. So what this information is saying is now this trinomial factors as a perfect square. Okay. So to factor it, well, you can use your A times C approach if you want. So A times C would be 4. Maybe I'll do that over here. So 4, that's A times C. Factoring 4 and trying to add up to a 4. So that would be a 2 and a 2. And this is a case where we have an A of 1. So as soon as I find these numbers, I can quickly write down the factorization. So x plus 2 times x plus 2 minus 1 equals 4. X plus 2 times itself would be x plus 2 squared minus 1 equals 4. So that is the thing squared now. Now I have something squared that if I isolate this thing, I can apply a square root to it. So I'll isolate it. So we have x plus 2 all squared equals 5 now. And now I can take a square root using plus and minus on the side with the pure number. So x plus 2 equals plus and minus the square root of 5. And subtract 2. So x equals negative 2 plus and minus the square root of 5. If you want, you can check that. So if I type in one of our answers, negative 2, let's just do plus root 5, I can hit equals. And then if I press this A and S button, whenever I press that, it'll think of it as this. So I'll go A and S squared, right? I'm plugging into here, plus 4 times answer, minus 1, I'm hoping this is a 0, and it is. So that's a good indicator that this is a good solution. Let's try another one. So here's one where we don't have x squared just sitting there. So the statement was if you have x squared plus bx, and then you add in half of b squared, it'll then factor as x plus half of b all squared. So I need to identify x squared plus bx before all of this can play out. And right now I don't have just x squared, I have 3x squared. So what I'm going to do is first divide everything by 3. So x squared minus 3x plus 8/3 equals 0. So now x squared plus bx is sitting right here. So our b is not the negative 9, it's actually negative 3. So b is negative 3. Half of b squared would be negative 3 over 2 squared. In other words, squaring, right, taking negative 3 over 2 times itself. That's what negative 3 over 2 squared means. Multiplying straight across, we get positive 9/4. So this is the number I will add right here, but also over here. Okay, so x squared minus 3x plus 9/4 plus 8/3, right? I'm just kind of scooting the 8/3 over, equals 0 plus 9/4. So now this piece is this trinomial, this entire trinomial, which now should factor as x plus half of b all squared. So x plus half of b in our case is right here. Right, this is half of b. So it'll be x minus 3/2 squared plus 8/3 equals 9/4. All right, so I used this information right here. It'll always factor as half of b. So half of b for our problem is right here. Negative 3/2, and that's why negative 3/2 appears here. So isolate, so subtract 8/3. I'll use my calculator as kind of an arithmetic helper. So 9/4 minus 8/3, negative 5/12. So x minus 3/2 squared equals, that was negative 5/12. Now that that thing being squared is isolated, I'll take a square root using plus and minus. So I'll go ahead and type in the square root of negative 5/12 into the calculator, making sure I have the calculator in complex mode. So the square root of negative 5/12. So that apparently is root 15 over 6i. So I would have x minus 3/2 equals plus and minus root 15 over 6i. And then I'll add over this 3/2, and that's it. So finally, we have our solution as x equals 3/2 plus and minus the square root of 15 over 6i. I'll go ahead and check one of those. So I already have that in there. So if I just go 3/2 plus answer, then that is the positive version of my answer. And now this thing is my answer that the calculator is memorizing as this button here. So now I can plug this in. So what I'll do is I'll multiply 3 times answer squared minus 9 times answer plus 8 and hope that gets 0. So 3 times answer squared minus 9 times answer plus 8. It's a 0. All right. Talk to you guys next time.